This is Dan Abbott. I am making this video for my AEDD 100 class in print reading at Southern Maine Community College. And I'm doing this because a number of people, in fact most people, had difficulty with the problem on reading scales. And I want to do a video that uses the specific exercise sheets. I did a whole presentation on scales using actual scales. But because there are so many of them, and they're scales measuring in fractional inch and 16ths, 32nds, and 64ths. There's scales measuring in decimal inch, where you take an inch and divide into 50 parts. There are civil engineering scales that take inches and divide them into 10, 20, 30, 40, 60, 50, that's it, parts, for using in ratios with any kind of civil project where you have very large differences in the size of the drawing based on and compared to the size of whatever you're drawing. Then there are architectural scales that start at 3/16ths of an inch, actually 3/32nds of an inch now that I think of it, and go up to 3 inches equals a foot. So there are a lot of them, and unfortunately you've got to deal with them in the United States because that's what we used. And if you're out in the field doing anything with technical drawings, at some point you're going to run into at least some of those scales. So I'm now on our home page in Brightspace. If you go to Content, I showed you this at the beginning, but just to make sure you know, if you go to the Content tab, there is a Resources unit under Content, and the Resources unit is Course Content, Module 00, General Resources. And a number of things here. One of them is all scales left, all scales right. And all scales left and all scales right are drawings, precision drawings, of all the scales we're going to use from the left end and from the right end. And the reason for the left and right difference is that the left end is where the scales start, but the scales themselves, the physical scale, the thing with which you'd measure, those things are about 12 inches long, a little longer, so they won't fit on a standard sheet of paper. So I gave you something where I broke down the scales into two pieces. The one on the left, it describes what those scales are: fractional inch, 32nds, 64ths, metric, decimal inch. Then the engineering scales and the fractional inch. One of the things you're going to have to do is get so you can recognize what those scales are. So you shouldn't need these labels once you understand them to look at a scale like that and immediately recognize that it's being measured in millimeters. This has the number 50, from 0 to 1 is 1 inch. So all of these scales, with the exception of this one, measure using an inch as the base measurement. Millimeters at 25.4 millimeters in an inch, and you can see slightly past the 25 mark is where the inch would line up. This is without question the simplest of the scales, and virtually no one has trouble measuring with that, even those of you that grew up with fractional inches. Those of you who grew up with the metric system find the fractional inch system and the engineering system and the architectural system cumbersome. The reason is because it is cumbersome. So what I gave you this for is so that you could print them out. And that's how you're going to measure, because otherwise you'd have to buy all these scales, since you're doing this class primarily, well, many of you are doing it on Zoom and others are doing it in person. But we don't have all these scales for every student, and if you were to purchase them, you could spend a couple of $100s on them. So instead what I did was I drew them for you. I drew them in a program called AutoCAD. And if you have a decent printer, and most of you do, and I misspelled the word left, I see right there. I just can't stand that. I've never noticed that before. I'm going to fix that. There we go. It's the left size. I also don't know what that 0 is there for either. Alright, that looks a little better. So all scales left side. All you have to do is go here and download this file. What I'm going to do is suggest you open it in Acrobat and then print it. Now when you do print it, you have to be careful, because in Acrobat, when you print something that uses a lot of the sheet, it will often give you the right paper size, but very frequently it is fit, which means it has been scaled, in this case 96%. That means you can't use these accurately. So when you print this, change it from fit to actual size. Now when you print it, it should come out. If it's a laser printer, these lines will be within 5/1000ths of an inch or so of where they need to be. So that's the left end of this, the one in which you've got all the, pardon me, all the labeling. Let me get that out of here too. all the labeling. So there's another one for the right end of it. What I am going to do is have you cut them out or fold them up or use some technique for being able to put this down on a sheet of paper and measure something. So I'm going to close this. The other one we have is the one, go back once, the one on the right end of it. And the difference is that on the one on the right end, I did not put the label of what kind of scale it was. You just have to be able to recognize it. But some of them still have a designation for what type of scale it is. It says MN here, that's common on a metric scale, 50 again common. Here it's not common for civil engineering scales to repeat the number on the left-hand side, but it is very common in architectural to have a different number on this end, so that when you're measuring from right to left, you're using a different architectural scale than when you're measuring from left to right. Now, 3/32, that means the distance from that line right there to that line right here represents 1 foot, but it measures 3/32 of an inch on a sheet of paper. Right below it, 3 inches, and I put these together just to show you the contrast. That distance from here to here is 1 foot on the ground at a 3/32 of an inch equals 1 foot scale. The distance from here to here is 1 foot on the ground at a scale of 3 inches on the sheet of paper equals 1 inch on the ground. Now 1 foot, on the ground. Because it's such a small distance, the number of divisions you can squeeze in that 1 foot is limited here to 6. That means every division represents 2 inches. Down here though, because 3 inches is such a long distance, we can divide this into not just inches but fractions of an inch. You know, you've got 1, 2, 3, 4, 5, 6, that's half a foot, 6 inches all the way down through. Well, if that's 1 inch, you've got another line here is a half an inch, a quarter inch, and an eighth of an inch. So at a 3-inch scale, which is called a large scale, it doesn't cover as much material on the ground, but it blows up the drawing of what you're drawing to a much larger scale, and it allows you in this case to measure accurately within an eighth of an inch on the ground. So that is the scales, and what I've done here is cut them out. And I cut them out so they look like this. So that's the same sheet you just saw. Now, this was, you know, I won't say it was fun, but, you know, maybe you'd get your kids together with you or somebody to help you cut them. And it's a little ragged down here, you can see that, but they're actually usable scales, very accurate, actually just as accurate as if you'd purchased those scales. It's just that they're a little bit flimsy. Now we go back to Brightspace, and I'm going to go up to assignments. The assignment here was to take 5 sheets and do various measuring exercises on those 5 sheets. So it is called the Scales Worksheet 3A to 3E. So I'm going to edit that. This looks a little different than you see it because you're a student. But the worksheet itself, right here, if I open that up, it's 5 pages, and what a couple of people have had difficulty figuring out exactly what I was asking for here. So what I'm going to do is I'm going to go and do one of the problems on the first scale, one of the problems on the second one of the problems on the third, one of the problems on the fourth scale, fifth, and the sixth. Now there are 1, 2, 3, 4, 5, 6 scales on this sheet. What you're going to do is tell me over here what the measurement is representing in each one of these numbers. What that means is you have to recognize what these scales are measuring in. This is simply the same scale you learned when you were in grade school. It takes 1 inch and divides it into 16 parts, and so these are fractional inches. There's no indication on this scale that it's used to represent a particular plot scale. So it just measures directly how long something is. So the numbers for 1, 2, and 3 are simply going to be a number in inches and fractions of an inch. Down below, we have an architectural scale, where 3/16 of an inch, the distance from here to here, represents 1 foot on the ground. And you can see it lines up with the 16ths up here. Now, this 0 doesn't line up with that 0. It's offset a little bit. But if you take a look at that distance measures 3/16, the same as this distance. These are two independent scales, however. They're both printed on the same piece of plastic or metal so that you can use them. And in fact, an architectural scale is normally triangular. It has 11 scales on it. One standard 16th scale usually, and then another architectural scale, and then pairs of architectural scales on all the other surfaces. This is another architectural scale. 1.5 inches equals a foot. That means the distance from here over to that 0, that distance is 1.5 inches. These numbers along here measure the distance from 0 out. From here to here, 1.5. From here to here is 1.5. The reason it says 2, and this also says 2, is that one of these measures starting from the other end of the scale. That 2 starts by measuring from the right end of the scale. This 2 is measuring, this 2 is measuring from the left end of the scale. So 0, 1 foot, 2 feet on the ground is being represented by that distance. 1/8 inch and 1/2 inch, also architectural scales. Down here we have some more architectural scales, but this is from the other end. 3/32 equals an inch, equals a foot. 3 inches equals a foot. 3/4 of an inch equals a foot. 1/4 and 1. All of them use exactly the same format, which is that there's a group of numbers representing how many feet there are on the ground for each of those measurements, and each one of them has, at the end, an area that represents whatever that increment is, at 3/32, broken down into enough or as many individual increments as possible within that foot. So for really small ones, you might only have 6, so each one represents 2 inches. For really long ones, you might have enough, so each increment represents 1/8 of an inch. Here, a little less than that. Each increment is 1, 2, 3. Each increment measures 1/2 an inch. Down here, 1 inch. Down here, 1 inch. Each increment is measuring 1/4 of an inch. So the distance from here to here is used to measure anything smaller than 1 full foot. Then down here we have the engineering scales. And again, I'm going to do an example of one in just a minute. And I do have a video on my YouTube channel that goes through and shows you how to use these scales on actual prints. I also went through this in class, but again, I'm going to do this so you understand what I want to see on these worksheets. 50 means that the distance from here to there is 1 inch. It measures 1 inch and represents 50 units of some kind. It doesn't matter what the units are, but most civil engineers in the United States would use this to measure at a scale of 1 inch on the paper represents 50 feet on the ground. Or 1 inch on the paper represents 5 feet on the ground. Or 1 inch on the paper represents 500 or 5,000 or 5 million. All you have to do is find the 5, which is right here. The distance from here to here is 1 inch. On the ground it represents 5 units. If you tell me that you're measuring in a scale of 1 inch equals 50 feet, then the distance from here to here, which is 1 inch on the paper, represents 50 feet in actual life, which means you'd put a 0 at the end of all these numbers. So the distance from here to here represents 100 feet. Now, if we're going with 1 inch equals 500 feet, the distance from here to here would be 500 feet. That means that would be 1,000 feet. That means that would be 1,200 feet. 2,400 feet. In other words, you'd keep adding the zeros based on the plot scale you're using. 30 is exactly the same, but we're dividing things up into 30 parts per inch instead of 50. 40 parts, 20 parts, and 10 parts. Now in here I want you to literally measure some things, and that's where I'm going to start. I'll go back to the other ones, but it's asking you to measure some things using various scales. So you have something you can print out, and again, print this out actual size so you can measure these things accurately. And I want you to measure that line and tell me how long it is on a sheet of paper in 1/16 of an inch. Then I want you to use the 1/4 inch scale and tell me how long that line would be on the ground at a 1/4 inch equals a foot scale. Then I want you to use the 1/2 inch equals 1 foot scale to measure to tell me how long would it be on the ground at that scale. So I'm going to switch over to my document camera. So here's the document that we're looking at right here, and there's the line we want to measure. Let me just zoom out a little bit. And now let's focus that again. Alright, so the first thing I need to do is just to measure it with the standard scale. Well, measuring it with the standard scale means I'm going to use this scale right here. Now, I've only got the left end of this, so what I'm going to do is do what I normally do if I'm measuring with a scale that isn't quite long enough. If I take a look at this, I'm going to go over and just stop it right here at 4 inches. Say from here to here is 4 inches. And I'm going to slide this over. And I'm going to put it right down here and measure that. I'm going to say that's 4 inches plus 1, not quite 2 inches. So the overall length of this is going to be 5 inches. 4 inches to that mark plus another inch is 5. It doesn't quite go to the 2. It stops a 1/16 of an inch shy of the 2. So the answer for this one is going to be 5 and 15/16 inches. That's how long it actually measures. Now we could calculate how long it should be, representing a 1/4 inch equals a foot, by determining how many 1/4 of an inch there are there. But the whole purpose of using a scale of a 1/4 inch equals a foot is so that you can directly measure the distance something is on the ground using a physical scale on a sheet of paper. So the scale I want to use is on the right end. So I now have my sheet that I printed out. It has the right ends of all these scales. So the scale I want to use is this one right here. So I'm going to cut it out. So I just cut this scale out of that sheet that I had, and there's my 1/4 inch scale. So I'm going to go back up to this line. Now I'm starting from the right end, and I'm going to start by just lining the 0 up with the end of that line. And I'm saying, all right, now I'm measuring a line on a drawing, on a drawing of something, and I want to know how long that line would be in the ground. If I come over here and look, the distances are starting at 0 and going to the left. So that's 0, that's 2 feet, so that's 1 foot right there. If I come over here and look, it goes beyond, there's 22 feet here, 23 feet here, 23.5 feet. So it goes beyond the 23 feet, but it doesn't quite get to the 24. So I need to determine how close it got, or how far away from the 23 it is. What I'm going to do is slide this over until the 23 feet, which is over on the left, lines up with the other end of this line. That means right here, that's 23 feet. By the way, I printed the sheet that I'm testing this on. I did not print this actual size. So your numbers are going to be slightly different, because I really want to make sure you measure this and don't just write down the answers I'm giving you. But you're going to have numbers that are pretty close to this. Now if I come over here with that 23 right here, I know that this is going to be 23 feet dash some number of inches. Now I can only measure in whole inches on this 1/4 inch scale. If I bring this down, we can see it a little better. Right down to there. Let me do one more focus. So if we look at this, it looks like that line goes to 1, 2, 3, 4, 5, 6, 7, 8 inches. So it goes 8 marks past the 0. So the answer here would then be 23 feet, 8 inches. Again, remember, when you print this out full size, actual size, your numbers are going to be slightly different. But they'll be very close to this. I didn't make much of a change in this. So that's how we're going to put that. Now what else I have to do is take the 1/2 inch scale and do the same thing. Now I could literally look at this and come up with that answer. But I'm going to use the scale instead, because that's what this whole exercise is about, having you learn how to use these various scales. The 1/2 inch scale, right there. Right there. So I'm going to bring this up again. We can see the whole thing. And again, if I'm an architect or if I'm doing drafting, what I'm going to do is have an actual physical scale that's about 12 inches long. And I did give you, I believe, a PDF file that does have the full length scale, but you just have to have it be able to plot on a large sheet of paper to do it. So the 1/2 inch scale is the one down here. So I'm going to measure this from the other end by starting to put the 0 on that end, because the half-inch scale measures left to right. So if I look at it like that, and then I come over here, what I can say is 0, 1, 2, 3, 4, 5, 6, 7, 8. Now that 7 happens to be the same in both directions. Don't get fooled by that. I'm going left to right, so there's 6, 7, 8. If I take a look at this, since I don't have quite enough scale to measure the whole thing, I'm going to put a little mark right there and say that represents 8 feet. Make sure that mark is in the right place. Not quite. I'm going to erase that. I'm going to put that right on the end here. I'm going to say I've got 8 feet. So the distance of that mark right there, that represents 8 feet. Now I need to do the rest of it. So how many more do I add in? I come over here. I have 1, 2, 3, not quite 4 feet in addition. So 8 feet plus 3 feet is going to be 11 feet. So the answer to this next one is 11 feet and then some numbers of inches. Now how many inches is it? You can see it goes almost to the 4. But to get the actual number of inches, we're going to move this over so it lines up with the 3 feet. And then come back here, and once again I'm going to count, and not just inches in this case, we can count fractions of an inch. Let me go down again where you can see that. Okay, now if I look over here, every one of these marks now is a ½ inch on the ground, because if I go 1, 2, 3, there's another mark in between. So if I look at this carefully, it looks to me like it's halfway between that mark and this mark. So if it's 6 inches to here, and 9 inches to here, and 10 inches, 11 inches would be right there, but it's halfway between, so 10½ inches. So now I'm going to say that's 11 feet, 10 and 1/2 inches. You'll have, again, slightly different numbers, but those are the numbers I want you to put over here. So for the rest of these, you're doing the same thing. You're measuring with different scales. So if I come down to this one, 1 inch equals 10 feet. What I have to do is find my scale. There's the scale right there for 10 feet. 1 inch equals 10 feet. And I'm going to measure that by going and doing the line. And if I had the whole scale here, it'd be easy. So 1 inch is from here to here. That measures 10 feet to there, 20 feet to here, etc., etc. So that mark right there is 50 feet. Bring it down again, and then check and see, and it's less than a whole inch. So it doesn't measure 50 feet here. Instead, I have to take these little marks. Well, there's 10 little marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If it's 10 feet from here to here, each one of those marks represents 1 foot. I've got 8 little marks, so the distance from here to here is 8. That line at that scale would be 58 feet. Now for a 20 scale, and we have a 20 scale here, if it was 20 instead, we look and you'll notice that there's a factor of 2 at play here. The distance from here to here, 20 feet, 40 feet, 60 feet, 80 feet, 100 feet at that scale. So now we got a different setup. 100 feet to here. Move my scale over to the 0. I say, all right, if that's 100 feet, and that means from here to here to here to here, the 1 inch is from here to here, that's 20 feet. So we got 100 feet. So what do we have here? That's not 20 feet now. 5, 10, 15, 16, 17. We're going to put in the 17, and maybe it's 16 actually. 116 feet. And that a 1 inch equals 20 scale is 116 feet. That makes sense. This is a smaller scale, and as a result it represents twice the distance on the ground that scale does. The 1 inch equals 300. We'll go and find a scale that measures in 30 parts. Get rid of some of this stuff. Put the 30 on here. So the distance from the 0 to there, what does it represent? Well, 1 inch in this case goes to here, so there's your 30 right there. But we're using 1 inch equals 300, so that's actually 300 feet, 400 feet, 600 feet, 800 feet. We come all the way down here, 1,400 feet, and we'll put a little mark right there, and we'll call that 1,400 feet. And again, if it's 300 feet from here to here, you keep going 1 inch at a time, and you come up with 400 feet at that mark. Now I'll bring the scale back over, have it line up like that. How far does it go beyond? Right about there. Well, the distance from here to here, 300 feet. So it's 300, that's 400. Halfway between 300 and 400 is 350. Put that down here. That's a 0, that's a 5, that's a 7, 1,750 feet. Now then down here we're going to be dealing with similar things. You're going to have a 3/4 inch instead of a 1/4 inch. You're going to have a 1/4 inch here. But notice it asks you the radius of this circle. The radius of the circle is the distance from here to here. So you're going to take your 3/4 inch scale that you cut out of this. Did I actually cut it out? No, I didn't cut it out yet because it's that one right there. But I would use that scale to determine what the radius of this is by putting the 0 there and then sliding it over. You can see the 3/4 inch, it's going to be less than 2 feet. That's the radius now. Actually, the radius is going to be, yeah, it's going to be less than 2 feet for the radius. Once you get the radius, you can determine the area of that. But then it asks you down here for the area in a 1/4 inch. At a 1/4 inch scale, that's not going to be about an inch and a half. I'm sorry, about 1.5 feet. Instead, at a 1/4 inch scale, I've now misplaced my 1/4 inch scale. At a 1/4 inch scale, the radius of that is actually going to be 3 times that. Going to be, in this case, there's 4 feet, goes beyond the 4 feet by 3 inches, so that'd be 4 feet 3 inches. So if the radius at a 1/4 inch scale is 4 feet 3 inches, you've got to convert that to a decimal. You've got to convert that to a decimal and then use the area for a circle to come up with the area in feet. Actually, in square feet. Let's go back. So this sheet requires that you draw some lines. So in other words, I'm making sure that not only can you read these scales, but you can also use these scales. So we're starting right there. That's our starting point. And I want to draw a line that goes from here to something. And I want that line to represent 8 foot 3 inches on the ground at a 1/4 inch equals a foot scale. So I come over here to my 1/4 inch equals a foot scale. What I'm going to do is first find the 8 feet. 2, 4, 6, 8. So I'm going to put the 8 right there. Now, 8 foot 3 inches means that I'm going to go 3 units beyond the 0. Since it's 8 feet from here to the 0, I'm going to go beyond a little bit. I'm going to draw a line right there. And now I'm going to draw a line that connects those things. And you can use anything you want to draw that line that you can use to draw a straight edge. Now I've taken all of my scales to school since I'm teaching at school. I'm going to use the edge of this piece of aluminum and I'm going to draw my line from here to here, and I'm done with that part. Now I want to measure that line to find out how long it would be. So on paper that line would be 2 1/16 of an inch. So over here I'm going to put 2 1/16, not 1/60th. I don't know why I put that in there. 2 1/16 of an inch. So I've got a line that I've drawn. I it's going to measure 8 feet 3 inches on the ground at a 1/4 inch equals a foot scale. And then over here on the side, I've got the actual length of that line. Now the next scale I need is my 30 scale. So again, this measures anything that you want to measure using a ratio of 1 to 30, 1 to 3, 1 to 300, whatever. This says 1 to 30. So if 1 inch equals 30 feet, and I need 95 feet, well, I'm going to go over here. I've got 30 feet, 60 feet, 90 feet, 95 feet right there. Would be 10 feet here, so from 0 to there is 95 feet. If you think of it, if I were going to guess in advance, which is a really good idea, I would have said, well, if 1 inch is 30, I'm going to need something over 3 inches. So, because that's 3 times that much. So that's where I'm going to draw my line. Again, take a straight edge. And I don't care what you use for a straight edge. And then take a photograph of it. If you're wondering how I grade these, I grade them by scaling them on my monitor to the right size, and I hold a template over it. Now, how big is that? How long is the actual line? Well, I'm guessing it's over 3 inches. And if I bring my scale over here, it looks like a pretty good guess. In fact, it is over 3 inches. That's in the 16th scale. Now, I had said to measure to the nearest 16th, so that's what we're doing. You notice it's kind of in between, but I'm going to say it's closer to the, I think it's closer to that one. So it's over 3 inches by 3/16 of an inch. So this would be 3 3/16 inches. So now I want to do an architectural example where you're not going to measure something, you're going to look at something that's already been measured. So these scales all represent various scales. So we'll take the 3/4 of an inch equals 1 foot scale. What is number 8? So number 8, the one that's going in here. Well, for this one, look over on the other end, you see it's lined up. It's lined up on the other end with the 7. So you know that we're going to start off with 7 feet because 0 starting here, the numbers are getting larger going to the left. So number 8 is going to start out with 7 feet dash and some numbers of inches. Well, how many inches? If you look right here, it goes almost all the way over to that point right there, almost to 8 feet. Well, how much is each one of these increments? If you look at it, the distance from here to here is half of the foot on the ground. That's 6 inches. That's 3 inches. That's 1 inch. In between is half an inch. So what we have here is 11.5 inches. That's the 11-inch mark. That's the 12-inch mark. So this is going to be 7 feet, 11.5 inches. That's what that's going to measure at a 3/4 inch equals a foot scale. Now we'll take a engineering scale example, and let's take one. Let's go down here. I'm going to take number 8. We're going to do both of those. I have just enough room to get them in here. Sorry about that shadow I just noticed. I can get rid of that. All right, so we're talking about here in number 8. So at a 1 inch equal, and it's the same distance over here on the sheet of paper. So we're talking about a 1 inch equals 20 foot or a 1 inch equals 2,000 foot scale. So again, we come over here. From here to here is 1 inch. It represents 20 feet at that scale. So that's going to represent 20 feet on the ground, 30 feet, 40 feet, 35 feet, 36 feet. So 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6. So at a 1 to 20 foot scale, that represents 36 feet, no inches. What would it represent at a 1 to 2,000 scale? Well, now this number is 2,000. That means that number is 3,000. That means this number is 3,600, which is going to add 2 zeros because 1 inch now represents a much larger distance. So the answer over here would be 3600 feet. And take a look at it logically. You can see that if that's 3,000 and that's 4,000, well, that's got to be 500. So 3,000, 100, 2, 3, 4, 500, 600, and you write it as 3,600. Now, this video is a little longer than I intended it to be, but I think it's fine. So I'm going to stop this. I'm going to give you the link, and I'm going to extend the due date on this because so many people struggled to figure out what I was asking in some cases. But also, you just weren't reading these scales correctly. There is absolutely no way we can move forward in a print reading class if you don't understand how to read these various scales. You've got to understand this. So make sure you really do put in the effort to know what you're doing and understand it. Come to the open session if you have to, ask questions in class. Just make sure that you really know what you're doing when you put those numbers down.